All right, so let's log in today. Yeah. Your parents told you log in.
They're right.
That's funny.
I got it.
So
My mom is in she's in India, so she can't
all right, so so hopefully you know how to do integration by parts. Um, so just knowing when to stop, when it's integratable, and you are gonna have a test soon. But this is gonna be the most difficult part. Is this part is not on the BC exam, but it will be on my test. But it's very important because it's on all the college tests. So College Board is dumbed down so much that this part is no longer a test. But if you take Calculus 2 anywhere in any type of university, it's gonna have one exam just on this.
Is it trig substitution?
Mm-hmm. Okay, so let's talk about trig integral, not trig substitution yet. So today we give a question. So integration. Which one? Oh. Who did that one? Whose handwriting is that? That's yours?
Yeah, that's one.
Oh, I was gonna say.
You have your laptop sharpened? Yeah.
All right. So let's start with sine to the cube of x, cosine to the fourth of x dx. Right. So this is some question that we kind of did before. And is to anticipate what u is and what du is, right? So you guys can all figure it as well, right? We did already? I show you how to do it? I'm just gonna go review again. So in this case, what u has to be? So what u is the
u is sine squared.
I don't think so.
What sine is?
Mm-hmm.
That's like the one you had earlier.
Kind of. One is 5 and one is 7.
Yeah, but just whatever the one odd, so you can choose.
Yeah, choose the odd one because odd one can split. So u is equal to cosine of x. Why is that? Because that's gonna give you sine of x times sine square of x times cosine to the fourth of x dx. And this one can change because all you gotta do is find out what this du is. Obviously, du is equal to negative sine of x. Does that make sense? And this one's going to be 1 minus cosine square of x times cosine to the fourth x dx. Now, this one here is the du. So it'll be 1 minus u squared u to the fourth, and this is a negative du. Does that make sense? You see that? Do you see that very beginning? U to the 4. Well, actually, I'm just going to distribute a negative sign in there. So that's going to be u to the 6, right? Minus u to the 4th du. So u to the 7 over 7 minus u to the 5 of 5. Plus c, right? Cosine of x 7 to the 7 minus cosine of the 5th of x plus c. And that will be the final answer. So anticipate what is going on. Now I'm going to give you a definite integral. I want to see if you guys can figure this one out. But check before you go in further. Check other person what a u is. And there's a definite integral.
Is that 3 cosine cubed x?
Yeah.
This is all just u, so there's no integration by parts.
There's no right part. They all trig. So it's LIATE is an LT. So therefore just pretty much manipulation.
That cosine to the 3. Like, does Sheldon like talk anymore?
What?
Sheldon, because he's been very quiet. I mean,
That's why I say too.
like last year math class, like you remember?
He's very quiet this year. I don't know what's going on.
Yeah, because every time I come, he's just been.
I know something personal happened, and I know one of the things, but I don't know the other thing. But again, yeah, no, I don't know.
Okay, never. I so
I mean, the answer is pretty ugly, but at least just plug in. Don't worry about simplify it because it even textbook use calculator to evaluate that. But the thing is, can you take a definite integral, indefinite integral?
these are like puzzles. Like the chess.com. I'm not. I really is.
It is. It gets more complicated because they don't gotta deal with geometry.
It's actually cool. You have to like plan stuff out. Oh wait, I think I got it. Yo, cooking. Hold on. Yeah. Oh, and Anthony, remember change your bounds. Oh wait, Mason. Oh no, that's fine. Okay, yeah.
Yo,
Yeah.
what's square root of 1/2? It's like,
Oh wait, no, that's not square. It's just 1 over square root 2.
okay.
Oh shoot, I was thinking. I was like, yeah.
Did you keep it as u and then change your bounds, or did you just plug it?
Oh, if you change it back here.
Okay, so yeah, so when you switch to u, you have to plug in pi over 3 for u. So square root of 3 over 2.
Yeah, so you just did this, but instead of sine, you had x, and then your bounds were sine of this and sine of that.
Oh, so there's no sign. There's a u of. One second. I did it too. Hey, bro.
I think you can do it either.
No, so yeah, what I did was dang it, bro. So I switched back, but you just use u.
Yeah, you don't want to do both.
Yeah,
and end up
I
getting
did
wrong.
like half this.
But you can switch back. Right?
You can.
You just have to keep the same.
But it's easier just to. Yeah,
What's sine of 5 or 6? That's like square root 2 over 3.
3 over 2.
So it'd be 2 of square root 3 over 2, 1/2,
That's funny.
minus 2 over 5, square root 3 over 2, to the 5 over 2, minus 2 to the 1/2, square root, and then minus 2 over 5, 1/2 to the 5 over 2 power.
Wait, why isn't it the other way around? Like, why isn't it 2 times root 1/2 minus 2 fifth 1/2 5 over 2 minus 2 root 3 over 2 1/2? Like, why isn't it?
Because you plug in the pi over 3 here is square root 3 over 2.
Okay, wait, why is root 3 over 2 on top?
That's a question.
Just the upper bound of the function.
I plug in pi over 3.
I don't know how to do trig. That's what I did.
Oh, you
I reversed the, yeah.
You know how to do calculus, you can do trig.
It's square root over 2, and square root 2 over 2, and 1/2. And
2 square root 2 1/2. Yeah.
no,
I got the whole graph.
Oh wait, you know what I did? I did cosine to sine. So okay.
cosine of 5 or 6 is 1/2. Cosine of 5 over.
No, because the 5 or 6 is square root 3 over 2.
Yeah, so I got the bound.
Oh yeah, because square root 2 is bigger than 1.
Yes, that's part of it. Yeah. That's
And
still
then-
annoying.
and then pi, because this is pi, this is a half, and a third is smaller than half, so it's big, and then
Pi of course,
that's 1/2.
pi of course is just the same.
Okay, so this ends up to be like very disgusting. I have this part, check it out with the book, but that part I just don't know how to.
731.
0239. If you use calculator, I have no idea what that does. Start with cosine to the 4th x dx. Now this one I will for sure put on the test. So the first example I give it to you, I will for sure put on the test. The second one is more or less the same as the first one. It just has splitting. It's not that bad. Now this one is going to be different. But this one for sure, I would say this is a test material. So first of all, if just sine or cosine, if y equals sine to the n of x, or especially n is even, or y equal to cosine n of x, this is even, n equal to even, then the only way to do it is to go by power reducing. And that's studied by power reducing. So first of all, I know my double angle was cosine 2 theta equal to cosine squared theta minus sine squared theta. We should know this because look like kind of like Pythagorean identity, but it's reverse. Everything's upside down. Now, of course, I can replace the cosine square. If I replace the cosine square with 1 minus sine theta, so that 1 minus sine squared theta minus sine squared theta, that's equal to 2 sine squared theta. No, actually 1 minus 2 sine squared theta. Is that okay? Now, that's not a power reducing, but it's very close. This is the double angle identity that we're looking for. Now, if we replace the sine squared theta with the 1 minus cosine squared theta, then that will be cosine 2 theta is equal to 2 cosine squared theta minus 1. Now, this all double angle identity, all three of them, not the second one. Second one is how to derive it. But power reducing basically just evaluate for that. So I'm going to switch this to there's 2 places, and I solve for the thing. So it'll be sine square of theta, right? And it's going to be 1 minus cosine 2 theta over 2. Does that make sense? I just change the place, solve for it. This is the first power reducing. We need to use that. We need to reduce the second one as well, but end up to be 1 plus cosine 2 theta over 2. And remember, they're not squares. They are just like this. So obviously, I can change this. How do I change it? Well, I can change the cosine square of x times cosine square of x. Well, let me do a better job. This, let's say 2, like that. Yeah. And we already know that, so it'll be 1 plus cosine of 2 theta over 2 square theta dx. D theta, sorry. I'll just use x. Any questions here? Because it's not possible for you to integrate cosine square theta. Even you change to sine square theta, it's going to be 1 minus sine squared. There was no du present. So the only way is to reduce that second degree to the first degree. And then here, I just had to use it twice. Now for me, I probably expanded just like, okay, well, this is a 1/2 plus cosine 2x over 2. I'll expand it this way. So if I expand it this way, it's going to be what? 1/4 plus what?
2 cosine 2 theta over 2.
Cosine 2 theta, 2x over 2 plus what?
Cosine 2 theta over 4.
2x over 4 dx. So we're doing okay.
Really change the x. Oh.
Yep, we have so far. That's good. So I can take an integral of this part. How about this part? So that's cosine square. I have to use double angle again, right? So that's going to be 1/4 plus cosine 2x. I haven't taken integral yet. I'm just going to be plus integral of, well, you got to be careful here though. So what will be the double angle here? But we can put 1/4 in the front and just worry about cosine square of 2x. So what will be here?
cosine squared theta squared.
No. I haven't taken integral yet. I just want to convert the cosine square of 2x. Does that make sense? What would that be?
Do you expand it so it's like cosine 2x times cosine 2x?
No.
and you-
You already have a double angle identity here. Just use them. Except this is going to be cosine square of 2 theta, right?
Would it be 1 plus cosine 4 theta?
Exactly. It just increased the argument, and that's it. Does that make sense? So that is going to be 1 plus cosine of 4 theta over 2. Actually, not theta, dx. Sorry. I kind of. Yeah. You just replace this with 2 theta. So theta becomes 4 theta. Do you see what I'm saying? We can split that. So it'll be 1 over 4 plus cosine 2x over 2 plus 1/4, 1/2. So what's 1/4 times 1/2? What is that? Well, we can just do 1/4 integration 1/2 dx and then plus 1/4 integration of cosine of 4x over 2 dx.
You get the 1/2.
Would it just be 1/4
Oh, wait, no, can you split a fraction? 1 over 2 plus.
Oh, I see.
I mean, you can do it either way. Either way is acceptable. So can I just add this is a 1/2, this is a 1/2. 1/4 and 1/8 is what? 1/4 plus 1/8 is what?
3/16.
No. 1/4 plus 1/8.
3/8.
3/8. There we go. Well, we can add. Right?
Take a little bit.
And integration, so that's going to be 3/8 of x, I think. 3/8 of x. So that take care of this too. What's integration cosine of 2x?
Sine 2x over 2.
Yeah, but it has 2 on the bottom, right?
Yes.
So it'll be sine of 2x over 4. And what's integration cosine of 4x? So it'll be plus sine of 4x. 4 times 1/4 times 2 is what? 32? And that's the right answer.
So only the last step is calculate. Everything else is algebra.
Everything algebra.
That's cool, yeah.
And trig. What'd you say?
A lot of power reducing.
Yeah, that's true power reducing. Usually on competition can ask you up to cosine fourth. On AP exam can ask you all the way to sine square and cosine square.
Is power reducing on like that?
Or there was simple one. There was the sine square. Not sine to the 4 and cosine to the 4. AP exam not gonna ask you cosine to the 4 or sine to the 4. But they will ask cosine square. May ask you.
Not very all.
That doesn't mean always.
No, he made a check for it's like
It was a nice birthday party.
It was after his party.
Birthday after birthday. What did you birthday?
Paintball place, Orlando paintball.
Did you win?
Hmm?
Did you win?
I did not win. A huge gash on my chest right here, but no one cares about that because that's the first entry I celebrate.
Okay, this is something you can take integral. Use the same idea before. Use the same idea before, but let's see if you guys can figure out this. Use the same idea before.
Show you why.
Yeah.
So what's the practical application of secant to the fourth 3x and to the third 3x?
Probably none. Just see if you can twist your brain.
Can you?
I mean, you can do sine to the fifth power and cosine to the seventh power. You can do this one. Just similar, same shit.
Sometimes during like
Potato, tomato.
Christmas, like holidays and stuff, Mr. Caparo would like hide secret messages, like Merry Christmas or something, in his like problems. Can you like do that? Can you do that? Make that?
I think I know which question you're talking about. It's something to do with natural log.
Yeah, yeah.
That I saw on TikTok.
All you, bro.
That's a pretty cool question. Whoever come up with that's pretty cool. I don't even remember. It was like Merry Xmas. And
Is there a power reducing for tangent?
no, don't use power reducing. There was no power reducing for secant.
But you could do like 1 over cosine squared and then power reduce the bottom.
Oh, yo.
No, think simpler. It's much easier than the question. It's similar to the question like you did today
Use secant squared.
in third period.
Secant squared can cancel you.
No, trust me, it's not worth it. It's not worth your time. It's right in front of you. This is just like sine and cosine. There's no difference.
Is it use of?
Yeah, this is basic use of. Just basic use of. That has nothing to do with power reduce. I can't believe I spent that long in third period. I was hoping to finish all the use substitution. I only finish indefinite integral.
Is that why you're kind of disappointed? Like you see.
Oh, am I at this point? No, I'm just tired.
That's what Gary had like 4 hours of this reading.
Yeah, this is
Wow.
My best period is my first period. We're talking about a whole bunch of stuff.
Oh yeah, no, my friend told me that. You're talking about something.
Yeah, I was talking about radioactive like trace elements, like radioisotopes, how they decay in half-life. And we talk about Fukushima, which is Japan, the nuclear waste. We talk about student loan. We talk about car loan, mortgage loan. I said everything you need to learn in your life is right here. It's more important than calculus.
Is my brother? Is he doing good?
He's doing all right. It's not you.
who's your brother?
He's not you, but he's all right.
What about Brandon?
Brendan who?
Brandon.
He's all right. He's smart.
I see. Use it.
I scare him sometimes on purpose. He gets scared. And I just gave him that face and he was like, I'm sorry, I'm sorry. It's just identity. It's not a bun.
Yeah.
You got it.
I just understand.
I think I have it. If I take the derivative of secant 3x,
Not that one.
Not that one. No, no, not that one. No one's bad.
I mean it's working though, like kind of. I think I did something wrong, but like other than that.
I'm gonna try it. Because if you bring it to the bottom, do power reducing, then you can flip it back up, and then it just becomes one fraction.
You do you, okay? I'm not taking that chance. If I can do something simpler, I'm gonna go with simpler. Remember, we have 2 hours this, so you gotta reserve some brain power for later stuff. Anthony, you cannot do this.
Wait, Jim, did you get how?
I'm smarter than Anthony.
Anthony's like, I have a quizzical.
Yeah, they said I got
Yeah, that's my bad.
Is tangent 4 to 3x over 12 tangent 6 to 3x over 18?
Yep.
Very impressive. See, even I change the question a little bit. The work, the operations, the idea is the same. You kind of had to play chess.
Yeah.
Man, I third period, I was like, dude, what is u equal to? It was like it was a integration of sine of x cosine square of x. That u equal to what?
Dang.
Cosine square? No.
it.
U
They've
equal to
used this before.
huh?
This is like their first time being introduced to it.
Yeah, but it was like, look, just think about what du is.
Everyone keeps saying they thought they did good on that last test. That wasn't the case. And then it's supposed to be like the easiest.
They teach the children how to think.
Hey, where are you, Anthony?
So I spent whole half here is
Yeah, that's it. It's fine.
let's just say put it this way. Last year, I think when we do integration of x times root x plus 1, there was like a couple students figure out. But the whole third period doesn't know what's going on. Like the backs up.
Yeah.
And like I think you figured out last year, and like I think Anthony figured out. And this year I cannot find one person figure out how to do integration of x.
We have.
We just went.
This Jared.
We have these.
At least it's alright. But at least at least figure out, yes, at least to figure out.
This is smart. Ria's smart.
Ria need to be taught. Ria is good grade, but
The Anderson is decent.
Anderson's alright. And I like Anderson
And
probably
Brady.
the most.
Brady's okay.
Huh?
Brady's decent.
Brady messed up some easy stuff. But he was better than I thought. He's better than Taylor. He's probably the second best out of Tanner. Tanner is still the best.
Is Raj good? Thank you. Neither is Raj.
Rajesh just got a 43 on his test. I was like, you got a girlfriend, your grade go down. I make fun
It
of
was a
him.
study.
Huh?
It was a study.
I know. Okay, so you guys know what to do, right?
Yes.
Just break up the secant square of 3x times secant square of 3x, because you anticipate that tangent of 3x, u equal to tangent to 3x
Will
is going to
cancel them
be
out.
cancel them out. And then this one is going to be, what is secant square root 3x can convert to?
Tangent square 3x plus 1.
Tangent square root 3x plus 1, right? So u equal to tangent
Yeah.
of 3x. du is equal to secant square of 3x times 3 dx. So that is going to cancel out. Dx, so it's going to be 1/3. And this one is going to be u squared times u squared plus 1 du, I think. Am I doing okay?
U to the third. It was 10 to the 3.
At the back third? Okay, sorry. This one is going to be u to the third then. So it'll be u to the fifth plus u to the third du. So u to the 7 over, oh no, I can't count. 6, right? Over 6, so it'll be 18 plus u to the 4th over 12 plus c. So even scary as that, it's going to be tangent 6 3x over 18 plus tangent 4 3x over 12 plus c. And that should be the answer. All right. Yep, that's right. Do you want to do one more or no? Yeah, do one more. Why not?
Photomat did some weird stuff.
Huh?
Photomat did some weird stuff.
Photomat's stupid, man. I hate Photomat. I actually use Mathway to create some questions sometimes because it'd be easier if you know the answer already and just make sure that it's legit questions. So Mathway is okay, but Wolf Outfront is probably the best. Huh?
I still don't know how to use
Really?
How to use it.
Mathway is easier?
Wolfram? I don't get it. Probably because I only tried to use one.
There's another one too. I forgot what is it.
Let me ask a pattern. I found a pattern between them. Like for these ones, like I think it's always gonna be like it was tangent plus tangent stuff like that. It's like,
Tangent plus
like,
tangent?
Not that, but like this, like you add 3, I think, to the u, so 6. Then you add 1, 4. Like the same thing here. You add 3 and 1. Like you add 4, 3 plus 1. You see what I mean?
Okay, last one. Now this is even power. Now there's no power reducing. That's okay. U substitution can simply take care of a lot of situation. You just had to get to a position that's integrable. So it's not too bad. I think it's manageable. But it's definitely similar idea to even power, but doesn't have any power reducing, I think. Yeah, it doesn't have any power reducing. It's use substitution all the way through. it's very clean. Very clean. But you gotta see something too, I think. So this one, I would say intermediate, but it's hard to see. But it's all the skill that you guys have. You got this one?
I'm just thinking.
This one's kind of interesting. It's just very simple, very clean. But to be able to see that very clean, you have to understand a lot of good math behind it. Puzzle. What's your highest puzzle? What's your highest puzzle? Oh, you have the highest one, I know. 46?
Oh, yeah, 47.
Damn, that's high.
That's crazy. I don't like bragging, but that was insane. I'll say that was crazy.
46 is crazy.
47. Hey, I'm gonna say 47.
47.
I earned each one. Okay, each one at that point is probably just like 10 minutes of thinking. I'm not even kidding. Like 10 minutes of just thinking each one.
You got a Hikaru. Draw a bunch of
It's
arrows.
crazy. Like, you can't.
Draw a bunch of arrows.
I have no clue how to get like. I don't know.
There's like the highest rank is like 600 something, you know that?
Like, that's-
If you look at the
how-
all
how
time,
did is that even a person? Like,
I don't
how can a
know.
person?
Because you look up the history, you look at the all time high,
Yeah, that's fine.
it was very high. I don't know how they come up with that.
I'm sure there's
And it was just very like a kid that looks like he's like just super nerdy looking. Hold on, let me check.
This is crazy. That he got to 54 in 3 minutes. Like, that's crazy.
That's Hikaru though.
Secant X. Secant is 0.
So global out time is 946.
I think that has to be a robot. I mean, I don't know.
No, it was like
The guy, if that's like the guy probably spent days.
Secant has 0.
There's no time. There's no time.
and he's not even a grandmaster. His blitz is only in 2300. Rapid's 2300, the deity is 1800.
I'm watching the video. He gets to like crazy.
Cool.
Are you sure it's
This is insane. Like,
No, I think the highest one he got 60 something. I have seen 16 something, 64, 68. But I think this guy's record is more impressive though. 600,
yeah, that's insane.
900 puzzles. There's no way. 900 puzzle is crazy. There's no way this guy's 900 puzzle because he lost to like 1200.
What?
Even lost to a 400. There's no way. That doesn't even make sense.
I just did all this work. I forgot that I was trying to find you. This
What?
No, okay.
All right. Obviously, it's tangent square times tangent square. Good job, guys. Okay. Tangent square can convert to what?
Minus.
10 square of x. Which is this one, you should know. Tangent square of x, secant square of x, minus 10 of x. Now this one's kind of tricky because this one is what? What is integration of tangent square? Because it's not on the trig integral, but it's indirectly on that.
1 over square root.
No.
Natural log.
No. Come on, it's simpler than that.
What's that?
Just do this again. Just do this again.
You do secant square x.
Yeah, so that would be tangent square of x, secant square of x minus integration of secant square of x minus 1 dx. And this is actually integrable. U equal to what?
Oh,
No. U equal to what?
tangent.
U equal to.
Dang.
It's really clean. I would tell you, this is really clean. So that is tangent of x. So that is gonna be u squared du, right? Is that okay? And this one is gonna be integration secant of x is what? I don't have integral anymore. This, oh yeah, I do have integral. Sorry, I haven't taken it. Just u3 over 3. Let's do integral. U squared du minus integration of secant square of x plus integration of x dx. So that is going to be 10 to the third x over 3 minus integration of secant is what? 10 of x and then plus, oh, this is a 1. Sorry. So this plus x. And between wait, hold on a second.
Do you think it'd be better if you kept one integral?
I'll just do it in term of x because I already plug in the x. What's tangent of pi over 4 is 1. 1 over 3 minus 1 plus pi over 4. 0, 0, 0. So it'll be 2 over third plus pi over 4. Let me check if this answer is right. I think it's right. Oh, negative 2/3. Negative 2/3, yeah. That was the only one as well. Yeah, it's really clean. It's not.
Yeah.
You just have to know how to play the chess match. It's not bad, right? Okay, let's go to somewhere fun today. So the next one is called trig sub. So all this thing that we did is like something you're capable of doing. You just gotta learn to practice singing. It's you're capable of doing. But now is we're gonna go to something you're not capable of doing, like this. It's not even a circle. It's not even a circle. So it's a definite integral. And is root of 1 plus x squared dx. And you're like, I never seen this shit before. You're supposed to have a 2x outside. It'll be easy use substitution. We can go home. Be done with, right?
Or you have to use like some kind of like you can convert it to like some
You're absolutely right. But the problem is there's a 3 option. There's arcsine, arctan, and arcsecant. So this is 3 trig substitution option that you can use. But which one would it be? Right? Which one would it be?
it's 1 plus x squared, so
I'll give you 3 choices. Arc, sine of x. Oh, actually theta. No, x. Oh. Actually, what I want to do. We just think about in terms of sine data equal to opposite over hypotenuse, and cosine data is equal to adjacent over hypotenuse, and tangent data is equal to actually, hold on a second, I'm just using secant. Secant data is hypotenuse over adjacent, and tangent data is equal to opposite over opposite over adjacent. So whatever.
So this is to do with like the roof, like the triangle that we.
Oh yeah, well, beginning year we had something like that.
So one is. One is one like.
You're right. You're on the right track.
So it's hypotenuse over. Wait, so that's h over a. That's secant.
No,
Tangent.
tangent is good, but you don't know why though.
Yes.
Because I guess the other two you didn't say anything.
Okay. Angle.
So obviously, that if you build a correct arrangement, you're gonna have square root 1 plus x squared. So where do you think square root 1 plus x squared more likely to be on? Which side? Which side is more likely gonna be square root 1 plus x squared?
Hypotenuse.
Why?
Because it'll be a squared plus b squared plus c squared. You get the square root. A
Yep.
squared.
Now, which side is gonna be x and which side is gonna be 1? It doesn't matter because we assign this angle. We always assign the bottom left as angle.
X would be the bottom, right? Or sorry, the right side. One would be the bottom.
Excellent. So tangent of data is equal to x over 1. Would you say? Tangent of data will be x.
Wow.
It's not done yet. It's only in the beginning.
Then you do identity, yeah?
Not yet.
Because 1 plus.
Let's take a derivative on both sides. What am I gonna get?
Bro.
What's the derivative?
Secant squared x equals 1.
Secant square of data. What else?
Uh,
D data is equal to dx.
Okay.
Just like your substitution, same thing.
Yeah.
Same shit.
But it's like backwards.
Trig substitution. That's fun. Okay.
There's a long question. Wait for it. It's a long question. It's not your. It looks like a very simple and
Yeah,
harmless.
I thought you'd
It's very scary. It's very scary. It's one of the most scariest question I have seen before. So square root of 1 plus, instead of x, what can we replace?
Secant squared theta d theta.
Secant square x, secant square theta, right? No, sorry. It's gonna be, wait, sorry. You're right, you're wrong. Tangent is x, right? X is equal to 10 of x, so it'll be 10 square of x, right?
And then the secant squared theta d theta is on the outside.
Yep. Don't forget that because you convert. Wait, this data now.
Oh, no, that's okay.
But that's not done yet.
Be the same problem. Yeah, if you do.
So that's gonna be secant square data, secant second data, d data. That's equal to secant to the third data, d data. Do you remember this? This looks familiar. This looks familiar. This is one of the hardest integration by part questions that I have shown you.
Integration by parts. But there's only one term.
Oh, yes. You do secant squared x is I. Because you can do the integral though. Yes.
di secant square x.
Yep.
Secant x. Secant x. 10x. 10x. Right? So plus minus. So it will be secant x 10x. Are we okay here? No, actually we're using data here. So don't get confused. I always get confused. Data. What else? Minus integration of secant of x 10 square of x. No, damn it. Why I always get confused? Data. Then there was it matter. Integration of secant there. Data. It matter, right? Wow, I'm putting Jared to sleep.
No, it's just very, you know,
What's the integration of secant 10 square data? Again, we had to use trig identity, right? What is a trig identity here? Tangent square data is what?
The secant squared data minus 1.
So that's why you need to know all your shit that from previous. And it becomes cyclic. Putting everybody.
What an innocent little problem.
What is a no problem, right? It's crazy. It's crazy. I didn't know it was so innocent until I first time I saw it. I was like, oh.
Square root 1 plus x squared.
So this one can move to the other side, right? So it'll be 2 integration of secant to the third d data is equal to secant data 10 data plus integration of secant data will be natural log of secant data plus 10 data. And then I just divided by 2 on all of them. So I'm going to divide it by 2. And I'm not done yet. I'm not done yet. You know it's equal to this, right? Then it's a half. What is secant data? Go back to the triangle. What is the secant of data?
hypotenuse over adjacent.
Oh, secant is
So that's
square
1 over.
root dx over c theta. Is that what you're saying?
No.
So that's where.
So you got secant of this, right? What is secant of this? The hypotenuse.
Just flip it over 1.
So it'll be what?
Square root 1 plus x
Square root 1 plus x squared.
squared.
Yep. Square root of 1 plus x squared. What's the tangent of data?
X. It's just x.
X, good. So it'll be x here plus natural log half of natural log of what?
Square root 1 plus x squared. Plus
Wait,
x.
it's a square root 1 plus x squared. Hypotenuse over 1, right? Yeah. Plus x. And there we go. That was the final answer. This is, yeah, that's inside the absolute value. Yeah. Not rebuff fall and sleep. And this is the reason why it's not an AP exam, but it's on my test. but it is a good question. But this is the longest question that you can see. This is the longest question that you can possibly think of.
You make the whole.
Make a triangle part is the hardest part, actually. If you build your triangle right, then everything is gonna kind of come back. Now let's rewind everything, okay?
We can't. So all right, and let me think about this, right? So here's what I'm gonna say. The reason the x is on the right side, the right leg, not the left leg, is because if the angle's bigger, so it has x has to be bigger than 1.
No, I always want to use those three functions: sine, secant, tangent. They're the easiest manipulator.
Yeah.
But if you place x1 there, then it has to use a tangent because you don't want to like tangent of data is equal to 1 over x, right? You want a constant to be on the bottom. Does that make sense?
Okay, makes sense.
You want a constant to be on the bottom. Okay. So for this section, the hardest part is to memorize the following three triangles. We already know one of them. So we know this one. This one is theta, right? And this one is x. This one 1. This one is 1 squared plus x squared. We already know this one. We says tangent of theta is equal to x over 1. This one is easy. The problem is, what if you have the other case? Okay, what if, so anytime you have something plus something, it's automatically tangent. It automatic tangent. Don't even think about it, just automatically tangent. So if you have, let's say, square root of a squared plus x squared. Sorry, 1 plus x squared. 1 plus x squared. So anytime you see the integral involved with this, and it's not integratable by your own rule, then you have to think about the tangent of x. The next one is gonna be kind of hard because you have two cases. You have x squared minus 1. You have x squared minus 1. Also, you have 1 minus x squared. Now, this is the one that you have to think about what triangle is supposed to be. So this is a triangle here. And we obviously at theta, we want to keep the constant on the bottom as much as we can. Right? So I want you guys come up with it and tell me what is the correct one. Because I still can come up with easier way to memorize this. You had to puzzle everything out. You want to keep constant on the bottom, and you only have 3 choices. So right now you have a.
Isn't the last one's a circle, right? Or half circle?
It doesn't matter. You want to do indefinite integral, so it's nothing to do with a circle.
You can't take indefinite.
Okay, gotcha.
Okay, so the problem is which trig function? You have 2 choices. We said tangent theta is one of them, sine theta is another one, secant is another one. So which one is sine and which one's a secant? So you guys gonna go discuss about it because I gotta come up with an easy way to remember this. And right now I just can puzzle it out, but I don't have a logistic reason or an easier way to memorize this. You have to use kind of common sense. Constant has to be on the bottom.
I think it's secant. Sorry.
This sign of secant. One or another.
Well,
50-50.
I think the middle one's secant, the bottom one's sine.
Why
I
that
think-
is? Why that is?
I think for the bottom one, the constant has to be the hypotenuse.
Constant has to be a hypotenuse. So you're saying this is 1? Okay.
The bottom side would be square root 1 minus x squared, and then x would be the right side.
1 minus x squared,
Mhm.
and this one is what? Okay, and you say this one is what? Sine. Okay, so let's see.
The sine of x.
Sine of theta is equal to x is opposite over hypotenuse 1. Very perfect. Okay, good. And then 1's on the bottom. And then in order to get this side, let's just assume that this is a z. So it'll be z square plus x squared equal to 1, z squared equal to 1 minus x squared, z is equal to 1 minus x squared. Good. So fit up here. Do you see that? For this one, the constant is on the bottom, so we say there's only option anymore. Secant theta, right? Secant theta equal to x over what? 1, right? So what is the hypotenuse here? X. And this adjacent, this is a 1. So this one is what? Imagine this is z. Imagine this is z. So z squared plus 1 squared equal to x squared. So z must equal to x squared minus 1, which is, wait, hold on a second. X squared minus 1, which is found out here. So this is the correct thing. Okay, so let's practice one. You guys ready? Dx over x squared 9 minus x squared dx. Oh, not dx, just dx on the top. You guys work together. Breathe out. You gotta get up.
Okay.
Work hard now so you can have easy life.
Why can't I was meant to be a bomb. That's my column. My true column. I wanna be a
I
bomb.
never see a brown person that's a bomb on
I
the
know we
street.
need more diversity, but
I swear I have never seen one. That's the one race I have never seen. I see white people. I even seen Asian people. I even see Chinese person. Yeah.
we need to get
I don't see any brown person. I never ever see a brown homeless person.
we need to get more engagement in the field.
Oh yeah.
Meant to be a bomb. It's like
Wait, let me see. I'm trying to recall my memory. Have you guys ever seen an Indian homeless person?
So, really, like you said, Asia, yeah.
I have seen like some Vietnamese people. I see one guy outside. I don't know if you know this restaurant, Pho Hoa. Do you know this restaurant? Pho Hoa. So there's one guy always outside, and he's like this, and he will be like this the whole time.
Yeah.
And he just walk outside, and he will walk right next to you, and he don't ask you for money. I feel really bad. I went to buy like a fur for him, and I give it to him, and the lady's like asking like, why you order an extra one? Because I usually never order extra one. He's like, oh yeah, I'm giving to the person outside. He said, oh, you don't have to give it to him. We give it to him all the time. And I was like, it's okay. I already bought it, so I'm gonna give it to him. And like every day he show up there, he's like this. He doesn't even ask for money. He's just like this, holding his thing. Huh? I don't know if it's his back problem. Like he's like this.
So,
Remember, at the end, you had to convert back to x. Okay. Now the length can be more than one. You know that, right?
Yeah.
This case, the one of the length is 3.
Where are you right now?
Three density will cosine beta over sine beta.
Did you do b beta?
So d theta is, so dx is equal to 3 cosine theta d theta.
Yeah.
So you use sine.
I didn't even get the notes. You moved on too fast, so I don't know where to start.
I'm sorry. So this part is the 3 decision you had to make. First decision, if you see 1 plus x squared, we already talked about it. If it's 1 plus x squared, you had to put in the hypotenuse. That's the only way you get positive sign there, because the a squared plus b squared equals c squared. So tangent data is equal to x over 1.
Squared.
The second 2 cases that we asked, like, I don't know, like, how is the correct way to think about it. I don't know. You guys can come up with a better way to logic it out. But for me, I just kind of think about what situation would it be and have a constant on the bottom. The only way to have a constant on the bottom and to get x squared minus 1 is it has to be x and z on the other side. Z is the third side you don't know, and you can figure out the third side. You can just memorize this, or you can actually reason it out. I think some of you guys can reason it out to figure out this is this case, and this is this case, and this is the one I usually don't memorize because that's the one you can get. This one I just kind of figure out a puzzle. So remember, you can only choose sine, secant, and sine, secant, and tangent. Since tangent's out of line, you only had a debate between secant and sine. And secant and sine has to be, if I have x over 1, then the other side has to be root x minus 1.
Like here. Think you factor out. So
Austin didn't even come to school today.
I shouldn't have gone to school then. I should have came here just for this class. I didn't do anything my first period, my third period, or my fifth period. First period is English.
Third period did 1 question.
Yeah.
Yeah, I guess the most talented person will be Anderson in that room.
Yep.
He just playing video game half the time. He play with his phone, huh?
Better than Elise.
Yeah, I will say because he play game half the time. He's not even paying attention half the time.
Yeah.
He's playing with his cell phone, right?
that's not for him.
And Wesley too.
So,
I'm gonna lock his phone. I'm gonna lock Wesley's phone.
he was defending his honor this today.
Why?
Somebody was getting at him for something, so he had to defend himself.
For Clash Royale?
No, like
Oh. What's wrong? He's a good kid though. I like him. I like everybody in their period.
what about Josh?
Josh is very good sweet talk though. He's very good at sweet talk, but yeah, I would say he'll be the only person that's
That's who's mom really.
I was pissed. I was pissed. I was mad. I was like, if that's my kid, I'll never let it get by. And the thing is, Josh is smart. He's very smart. He's not dumb. If he's dumb, then I'll be mad. I'll be like, okay, whatever. But he's very smart.
I'm pretty far, but I'm just gonna stay. So, I did all the substitutions. So the first one was 3 goes
Yeah.
here, yeah. Then can you do that? I think you can. Back up.
Oh, it's 3 squared. Yeah.
So then it'd be 3. We have 3. You cancel that. So it's 1 should be 1/9 cosine theta.
Oh.
You see that?
I did square.
It's right there, but then I was like here.
Is it over?
So Reba, draw a triangle first.
Yeah, wait.
Figure out what the data.
1/9.
And I think one easy way, if you have hard time figure out, just knowing the derivative of arc sine is like 9 minus x squared, right? So that you have to say is, well, that has to be arc sine, right?
Yeah.
So arc sine is, so this is a sine of theta. Well, this one has to be x over 3. So this one is x over 3. Because this side will give you, let's just assume this side is z. So it'll be x squared plus z squared equal to 3 squared. So z squared is equal to 9 minus x squared. So z equal to square root of 9 minus x squared. So which is perfectly for the question. Do you guys see that? So I guess one easy way, if you don't have reasoning, you know the derivative of arc sine anyway. So it has to be sine. So I think that'll be an easier way to remember that. You don't have to figure out which piece is which piece. So let's just start with x equal to 3 sine theta. Do you see that?
Yep.
Reebok, do you see that? I just moved a 3 to the other side. So x is equal to 3 sine theta. And then you also solve for dx, which is take a derivative. So it'd be 3 cosine theta d theta. Now just substitute everything there. I'll give you some time for you to substitute. Once you get first question, you get hang of it. Every time it's gonna be much better each time. So I'm gonna convert all the x to theta. I think you already way past that, right? I'm just waiting for rebuff.
Yeah.
So I'm gonna write down dx equal to 3 cosine theta d theta. And the x squared is gonna be 9 sine square theta. Square root of 9 minus 9 sine square theta d theta. Oh, I don't need d data in the back. Okay, so now I just need simplifications. So this one is gonna be 3 cosine of data d data. 9 sine square theta. And this one is gonna be what? This one is gonna be 3 times cosine square theta. Is that okay?
Huh? Okay. Almost.
So this cancel out with this one, right?
You got it?
1 over 9.
One second, one second. I have a crazy plan. This is good, this is good.
1 over 9 of a cosecant square theta. D theta. Do you guys see it?
Huh? One second, one second.
Read back the question.
How does 9 minus 9 sine squared theta become 3 root?
Okay, I'll do this.
Oh, okay.
And then this is 3. 1 minus sine square theta. 3 cosine square theta. Right?
I think I got it.
You got the same answer as me?
Oh. Yeah, I went into a different way. Or did I?
Negative.
Wait, what?
That's equal to negative 1 over 9. Cotangent theta, let's go back, look at the triangle. Cotangent is
Why does it become negative?
because integration of cosecant is negative cotangent.
I switched to
This is square root.
Over x.
This is square root.
Yeah.
I did no, I did cosine square plus sine square. I was doing the coolest.
No, yeah, you did square root. I was
Sorry, cosecant
I had the
squared.
best plan, dude.
You got 2 more tries.
Dang. That's
Well,
that was
well, sorry.
cool.
Actually, I got
Yeah, this one's easier. This one's easier because this one is I love when it's positive because it's a whole lot easier. This one everybody can get it right, even Rebuff. Rebuff's kind of out of it. Yeah, 4x squared. Integration of secant.
Mhm.
You should know that one. But you're on the right track though. Depend. Do you have a constant in the front?
On the bottom.
Which is what?
2.
Good.
I think it was ln secant x was tangent x.
Yep.
Yep. You substitute.
Yeah, this one's a lot easier.
This one's not too bad, right? This one's manageable.
Negative.
It's positive. Integration of secant is positive.
1 plus tan squared theta is secant squared.
Yeah, this.
And then
That's the same thing.
oh, then you bring you bring the 1/2.
1/2 natural log root 4x squared plus 1 plus 2x. We have how much time?
Right. So you can like take that one. This is what I'm kind of. The secant theta is ln secant x plus tangent x.
Last one. Bring drain. Last one's okay.
Yeah. Yeah, then look now there. And you bring it up the track. The track. So you want to find what you want to find secant x is and then tangent.
Now, if everything already in, even the boundary in terms of data, you can just take integrate length. You don't have to come back to x, okay?
So that's the answer. Then secant x is one of the.
Hold on, let me make sure I copied down the question right. Oh, I didn't copy down the question right, sorry. This ration is wrong, so it's 3/2.
Tangent x, you can say is 2x.
3/2.
Okay. So secant is
1/cosine.
okay.
Cosine is that.
Yeah, that makes sense.
So when you have definite integral, it's much better to do everything in terms of data, even the boundary in terms of data. So you don't have to convert back to x and to plug in x, which is too much pain in the ass. Then you're just gonna do it in terms of data. Everything is data, boundaries data. This one should be easily taken care of. And this is something that you know how to do. It's not something that you are gonna not memorize.
Is that 3/2?
Yeah.
Yeah.
Wait, I'm gonna have 4 more observation. 4 more observation. I swear that lady never come check me. Which is good. Do it everything in terms of data, even the boundary. Then you can take care of things right away because of this. It should be an easy question.
Huh? Where'd you get from?
Where was it? I'm trying to.
What if I don't want to do inverse? Do the normal boundaries? I feel like it can't be that bad.
Come on, you know what's inverse 10 of something.
Two.
All right, fine.
It was like big numbers.
Who's Austin, man?
Going crazy today.
What'd you get?
3 minus square root 2 over 2.
Very impressive. It's not that hard, is it? You guys just shoot through this thing.
I
Is
got
that-
stuck for a second on because I forgot to do dx to d theta.
Hmm.
But then I remembered.
Reba, have you got it?
No.
Can somebody help out Reba? Trig substitution is not that bad, right? Just it had to be really disciplined. You cannot mess up like small steps.
You can just keep that as too. Or just like keep the. So you have 1 over this cubed, right? So what's this? No. Yeah.
I think the first one is hardest one.
And there's just so much more stuff.
Yeah.
Yeah.
6 period.
Right.
Huh?
6 period.
If everybody show up, this pair is fun. Sometimes Reba don't show up, sometimes Austin don't show up.
We'll just move it.
I'm okay with like just 4 of you guys or 5 of you guys.
That's pretty fun. Yeah. It's chill, you know.
I mean, you don't need to do that.
6
Just
pair
put that-
added
put
the
that in your-
Marcos.
So what's your language?
He's always like weird noises.
Integration.
Like drive me crazy. I don't think so either. I think the Shakespeare had some weak link. Probably like right now, Ilya Beta, Pyro,
I think
that
you're right.
way.
It's weird how you break it.
and
Yeah, you're right.
either
Just look at it.
Nathan
Yeah,
or
Oh, okay.
Nathan or Armin. They'll be like a pretty weak.
I remember Nathan was pretty smart.
Nathan, if we lock in, is fine. The problem is like
Okay.
he's very laid back.
Is it seeking?
He's more laid back
Yeah.
this year than last year because his mom doesn't care about grade as much. His mom used to care about grade a lot.
Yes. So what's the next step?
It'll be
So if those people pick it up, it'll be fine. I think Veda will be fine. Ilya will be fine. Yeah, Red Veda put a lot of effort. So, but sometimes she doesn't grasp
You have
thing
words,
like
you can't
in
deliver.
if you change your orientation a little bit, she could throw off very easily. So you have to like give her a lot of different time to do it. But she's fine. She's like she had problem with that
Yeah.
integration by part problem.
This dx.
Mm.
So what you need to do to make it integratable.
Oh,
So
split it.
It's like it's
Not
like
split,
brand
you have to give it- give it-
Brenner is very fast.
So I said use
Like he was doing some weird stuff.
Well, yeah, but it's not.
Yeah,
that's not-
Is it
yeah.
not?
He's
I mean,
he's
it's
good.
not data,
He's
it's
he's
like
good.
explain.
He's good. Brenner is good.
So you need to
Brenner.
figure out what
So all the BC out of
Also skip.
double auto skip one is not bad. Julia is very fast, very efficient. If it's locking,
So
she's
find
fine.
one.
But yeah. So
Julia, Charlie, Charlie, Jarrett.
and Brenner. Yeah, I would definitely says they are worth to be in the single block. They don't even need to do double block. They all like just do.
You probably could.
If a double block and I can
Yeah.
this year I can probably take a lot more. Even like Rajosh and Ethan, if
No, you
they
can definitely know.
Rajosh Ethan can definitely do single block as well. At
Nathan
least,
should have taken it.
huh?
I think Nathan should have taken it.
Nathan would it be fine too? Nathan. So all the A students this year right now they can probably take a single block because all the A students are very good. At least Nathan and
Sophia.
Sophia probably better to do 2 years. But Sophia is smart.
Does Nathan come for lunch?
Yeah. He's a Hispanic kid.
He's a
He's one of
soccer
those-
kid.
one of those walking the other basketball court kids.
Oh, that guy. Oh, honestly.
I think yeah. I don't know. I don't think anybody gonna not pass. I don't think so.
In BC.
I think so.
Yeah, I think everyone's pretty smart.
I just worry about if they're gonna get 4 or 5.
It's bad Devin missed out so much. Like he's behind.
He missed out the rotation.
He didn't complete missed out shell method.
Yeah, that's not on it.
I guess it's not
Like
bad.
here, like from this step to this step.
Yeah, Devin would be weakest one there
So you need to either.
because he's
make your
not.
boundaries
He
perfect
missed
data
2 weeks of school.
Like you
Uh,
think your pass rate's gonna be a lot higher. Last time you said that you had like 80.
So like here.
Last year I had 86.
Yeah, so you use like this, or you doing this triangle.
Yeah, this year should be higher. Should be like hopefully 95. Hopefully only one student fail. If not,
What I'm
nobody
putting
fail.
in-
Yeah, I can't even figure who it fit.
So
I thought everyone was fast.
No, at end of the year, a lot of seniors gonna slack
Okay.
off.
Yeah.
A lot of seniors gonna
Okay.
slack off.
oh okay.
At end of the year, last year we have a lot of seniors too, but it was just everybody's pretty much the people will pass for sure. The only people didn't pass like Sergio.
And then this is
Sergio is like never did anything. Emily never did anything.
So wait, who else did pass? Sergio.
Sergio, Emily. Sergio's the only one in the period in pass.
What, do you remember what Emily's last name was?
I don't know. She do weightlifting.
Oh,
Or the second thing.
yeah, she went to. US.
And Sydney is always bad at math, so that's okay.
Oh, wait, she's the one. She's a senior this year, right?
Yeah, she's not good at math, but she tried. I think last year she didn't try. First year she tried.
Dang.
You said she's a senior this year?
Yeah.
So she's
So she took VC last.
Yeah, and she is one of the people didn't pass either one. But I think by the time when she go college, she take the class would be easy, easy cake. It doesn't really matter. Exposure is matters. So
this is like
uh, trying to think who else was it? Emily,
Is it
Sydney.
pi or pi 2?
Oh,
Okay, yeah.
what's that kid?
Oh, wait, no, it's pi 4.
7th period.
You can do inverse
Wait, no.
cancer.
No, that's the year before 7th period.
But I didn't.
Zach. Yeah, Zach.
Oh,
Not Zach Wingo Target, but Zach the other one. The white one.
I'm so slow.
Baseball kids all pass. Man, baseball kids was really bad. I don't know if you guys know Derek Lopez, Will Robinson,
and Robert, yeah.
Robert. He'll be like,
our periods, that is.
huh?
Wasn't Will that guy always like occasional no or occasional?
Oh yeah.
One second, but
He's just
He's crazy, yeah.
he's the fun. Yeah, I hopefully this year nobody fail. I want 100% on BC,
Okay, alright.
100% on AV,
instead of
and I'm done. I should retire after that. It's gonna be like,
and then I just did sine of theta is equal to.
What about pre-calculus stuff? You see people fail that?
pre-calculus, some kids not.
They use the data I'm trying.
They're not. They are like a very.
Okay.
No, everybody try it in pre-calculus.
Really? Oh, okay.
Like only people that says probably really missing a lot of knowledge and missing, like be able to catch on the knowledge. I think like those two person has one's going through something and the other one is. I'm more about Jada. Jada, she's such a sweet kid, but I don't know if she will pass or not. Because when she sees something different, she's like, it's like a lot of times like this student that when see something is awarded different, they don't know how to do it anymore. It's completely like they never think before. They don't know how to.
She doesn't really understand the concept between like it's always something isn't understanding it.
Yeah,
Like she'll try to know it, but she won't.
Just memorize how to do
it's not retaining it.
Yeah. That's why she's so hard to teach. 'Cause it's like
I find that
she
attractive.
doesn't once she gets like the example, like the example, she doesn't really.
Yeah, she can do that question. If you show him how to do that question, she can do 100 times, and she'll be fine.
Yeah.
But if you give him the question just slightly change, and she cannot adopt anymore. And that's what I found out this year's AB
My
student.
attraction to Jenna is pure.
If I change it a little bit, they just cannot see it.
She's like, my top, she's like very sweet and bubbly.
She's very
Is she like that?
Oh, she's very nice.
Yeah.
She's just like dumb as rocks. I can't